activate the stream? Okay. Hello, everyone. Good evening. Welcome to our first. Okay. Welcome everyone to the first workshop. So this, we are going to start our first series. This one will just be an introduction, and then this will be like this is a collaboration between CSG and the CSC. And then, so first thing is, please do sign in. And also we have a link at the top of the bar where you can ask questions. I'll be monitoring questions and in the chat and also in like the link there. And please do sign in for metrics wise. And I also have a link to the slides at the bottom. Actually, I don't think that link is correct. Hold on a sec. Embarrassing. Yeah, I don't think that is the correct link. So let me. Hold on. Okay. Yeah, I think that is the wrong link. So let me go and update that. So this. Oh wait, yeah, no, that's the correct link. Sorry. Okay, so the link seems to work. So if you want to follow along on the slides, the lower right link will be on every slide, and that'll be just the link to slides. If you want to follow along on your device. I still see some people looking at the QR. I think. Okay. Welcome, people. So I will go on to the next slide. So first, a little about me. My name is Henry, and on Discord I'm known as the Kid of Ukraine. I'm a master's student. I am the chairman for the CTF committee for CSG. On my own time, I play CTFs competitively on Perfect Blue. And then, we are the top team, just slight flex. So I will now introduce the committee. I'm the chairman. We have I think we have, those are the list of the committee members. I underlined those that are the CSC officers, and then there are some that are CSG officers. So I guess whoever is here on the committee, please just raise your hand. Okay. So those people who raise their hand, those are the people that are on the committee. And I will go to the next slide. So first of all, I will go kind of start with describing what is security. So what is security? What does it mean when something is secured? Does it mean that it's just a secure lock? But what if that lock that you have now, you can break it completely? Or maybe you can circumvent it somehow. Doesn't mean, is it something secure if, let's say, you have a strong password? Well, what if that password gets leaked? Then it's not secure anymore. So what about if you have some fancy code that verifies I am who I am, but then what if that code that you wrote is buggy? So clearly security is more than just following a series of practices. So one of the ways that kind of what security can mean is you have to make sure you cover all your bases. And this idea of I can what if I wrote something that subverted your expectations of what it means to be secure? Then quick video, which I think the sound should work.
Something funny happened to me. I want to tell you a story how I got a free burger when I ordered food, and use it to explain what injection vulnerabilities are. So last night I was super lazy, didn't want to cook, so I ordered food. I ordered food there before, so certain fields like the address were already filled out. But also the comment field was still filled out. And on the previous order, in the comment field, I requested a different sauce for one of the burgers. I didn't realize that and just continued and paid online. A little bit later, the delivery guy shows up and told me that he changed the sauce for the country burger as I had requested. Country burger? I didn't order one. He said, yeah, you did. Look here on the receipt. And I look at it and I realize what happened. The comment I wrote was printed just above the other items that I actually ordered. I used capital letters to emphasize my request back then, and I didn't notice that I just made it look like it is one of the ordered items. And so he actually thought I ordered a country burger, and the comment after it was just my modification request. I mean, looking at it now, everybody would say it's pretty clear that it's not an item I ordered. There's no price on it and it's not bold. But this is a fast food restaurant, and those guys have a lot to do. It has to go fast, and maybe comments are also not a common thing. I can totally see how it happened. I offered to pay for the burger, but he said it's fine. So that's how I got a free burger through an unintended burger injection or unintended social engineering attack. So what does this teach us about injection vulnerabilities in software? You see, programs are just acting on instructions that they have been given. Like a guy in a restaurant has instructions he gets from the order that gets printed out. And in this case, data, or this comment, was mixed together with business critical information. And whoever created and printed out this order didn't make it clear to the entity that processes this data that this is just a comment and not an order instruction. The bill could have been structured differently so that it's more clear. And this is always what happens with injection vulnerabilities. Let's take SQL injections. A programmer writing code that builds an SQL query and doesn't make it clear that this user data is just a string by wrapping it in quotes and making sure that no quotes can appear in the data by escaping them, then whatever processes the query can be fooled. Or cross-site scripting. The programmer writes user data into a surrounding HTML document without explicitly marking this data to just be plain text without special characters. Thus somebody can inject HTML tags like script tags and perform a XSS attack. And obviously, there are many cases in security where the underlying security issue is an injection. Yes, SQL injections and XSS have a very different impact and are very different, but only at the surface. The underlying principle is exactly the same. So whenever you place data into some other structure that gets then handed to another entity for further processing, may this be a web server, a database server, or browser, or a fast food employee, you have to make sure your data is clearly marked as what it is, just data, not an instruction.
Okay, this is a little quick video. I hope we don't get copy strike from that. But yeah, so that is, I think I can just press F11. So that was a very quick example of like what kind of we are looking at. So this is kind of another silly example. So here we have a very secure gate, and it says keep the gate closed and locked, and clearly it is locked, but it's still not very secure. Can someone tell me why?
No fence?
Well, there's no fence. You just walk around it. So this is one other example that even though you have some security, you followed all the security practices, there's still room for other exploits, aka walking around the gate. And I think someone asked what was the link to sign in. If you follow the link on the lower left corner, that should link to slides, and it'll be the second slide where you do the sign in link. So you can just use it that way if you are having trouble. So what are CTFs? So generally, when we're looking at CTFs, we're looking at different types of challenges. You score points. Some challenges are more difficult than others, and then so therefore they are worth different number of points. And this is called a Jeopardy style. And what you do in a CTF is you have these kind of challenges where you try to break some stuff in some sort of security thing. And there are lots of different categories, and hence there's a lot of different things you can actually do. And these are some of the categories. So mechanics, basically when you're looking at CTFs, you're applying some practical knowledge that you learned either from websites or like different tutorials, and then you try to exploit those things in certain classes of cyber security vulnerabilities. So they're usually like very fun challenges, puzzle-like challenges. They oftentimes, when you're looking at this, looking at CTFs, you're generally better off just being able to problem solve certain problems rather than having a good broad knowledge of different general textbook knowledge. Because a lot of times you're applying stuff that are not in the textbooks. So many categories basically means you can actually do whatever you can find something that you might find more interesting than others. So like maybe you like you don't like doing assembly or like doing low level stuff, which I think is a very common common shared ideal from a lot of people. I don't understand why, but if you don't like that, there are a lot more high-level stuff, aka you can look at web stuff, or you can look at crypto, and those are kind of different things. And then, so some careers, and when you're looking at cybersecurity, there's a lot of careers when you learn this stuff. So it's not it's completely useless and just fun and games. So like you could be doing on the red team side, so like pen testing, application security, or like stuff like that, or you can be on the blue team, and then you are looking at you're looking at how to mitigate these exploits. You're looking at what happens after you see other attackers attacking your stuff, and that's like incident response and stuff like that. And CTFs, they help you build a lot of those technical skills that you can then use for other kind of careers afterwards. They're generally more deep dives, but it's definitely nice to learn kind of a very deep knowledge, and then you can use that to apply to a lot of different things. So now I'm going to look at an example. So here we have some PHP code. So here so I have a live web server that is live right now. Now you can visit. And then let me shrink that. But you can see that it is a name field in an age. So if I type in my name and then my age, and then you can see a response that from here saying that welcome, you are 100 years old, and you can see that this is exactly what the code here says. So it takes in the parameter name that you gave for name, and then places it there, and then you are some number of years old. So note that the age field doesn't have to be a number. So I can actually put foo, and then it'll just put in that. So that's kind of interesting. There's no sanitization or input checking. So what happens if I put some other weird stuff? So let's say, I know HTML. I wanted to maybe do, let's say, bold. And look at that. It's now bold. I can even make it italic. So well, this is very fancy. I can basically do HTML formatting. This is a very cool thing to do, but turns out that's also very dangerous because I can then do this, add a script, JavaScript in here. So let me do this. The very typical thing, and then what happens? Oh, I get this message. And so, yeah, this is actually kind of dangerous because let's say if this was on some actual server that actually had some private data in there, I could actually run JavaScript and then just take control of that information. So, I think.
Is that how assembly works?
Wow, are you? You trying to embarrass yourself?
No. I mean, this should be web, right?
This is web.
If it's a CTF challenge.
It's a very simple example.
Oh, I don't know.
Okay. So this is a very small example of what you would call an XSS attack. So what is XSS? It is basically you're injecting JavaScript or injecting scripts into HTML or something like that. And you can see that this user input actually results in this alert. So that's a simple example. Now the next example, we have this thing.
Ooh, that is not.
What is?
It is Python.
It is Python, yes. So take a brief moment to take a look at that code. I also have a link here that you can run it. So, did I hear? Huh? That's right. So, can anyone so here we have some interesting code. It looks relatively simple, but then we have this interesting thing here so we have this interesting code saying that you have become a millionaire, and then it turns out a flag. And generally, when you're looking at CTF's the flag is basically like the output that you're trying to get. And then when you submit the flag, you basically get points. So that's kind of what we want to go for. Now the question is, how do we get there? I see.
What's that?
Guy in purple. Sure.
Do you use like an overflow or something? You put in like a buffer with some buffer overflow or something that's like more than what 2 of the.
Oh, okay, integer overflow.
Yeah,
So
integer overflow.
so let's try. So let's say.
Can you zoom in on it?
Oh yeah, I can zoom in. Okay, that should be enough.
Yes.
So let's try, what, 2 to the 32 power or something?
Sure.
Let me let me just open up Python and do that. So this number, we will try that.
Maybe add one more to that.
Add one more, 7.
It's gonna try to
Revert it back.
subtract this.
So it looks like we don't have enough money to withdraw. We still have $1,000.
Try minus one.
Try -1. Okay.
Work to that original number.
Oh wait. So what do you want me?
Use that number.
This number?
Yeah.
Oh yeah. Okay. Okay.
What about withdrawing negative money?
Ooh. What about withdrawing negative money?
Wow.
Okay, we can try that. Let's say how much? Let's start with -1.
$2.
-2, okay.
That's not even enough by
Oh, nice.
Oh, look at that. We now have $1,002.
more than $1 million.
Okay, we can do a -1,000,000. Something like that. I think that's, oh.
Oh,
Oh, look at that. We just became a millionaire.
there's no flag.
Oh, well, there's no flag because this is running in a random environment, but you know, if there was a flag here, we would have won. To be fair, I took it from somewhere else. So that is the infinite money. And it's also secure. So I do not see any other questions. So now I'm going to go into like categories. So the first one is cryptography. Generally, when you're looking at this, you're given some sort of algorithm or some sort of cipher algorithm that's encrypting or decrypting some message, and you want to break that implementation. Let's say RSA. In theory, it looks like it's actually a very strong cipher algorithm, and it's very hard to break because if you know a little bit about RSA, you know that it's based on factoring numbers to get the prime factorization, and that's hard. When the numbers get really big, that gets very hard to do. However, there's a lot of ways to implement RSA that are less than optimal, and you get instances where you can actually exploit it still, even though RSA is hard to break. And same with AES. You can implement AES in some ways that are very insecure and will basically be breakable. And then there are resources. I know that CryptoPals is an older resource. It has a lot of the basic fundamental crypto challenges. CryptoHack is something that's nicer because you can actually submit stuff to it and it will check whether you did it correctly or not. So definitely recommend CryptoHack if you're interested in that. So Python is generally most of the time used when you're looking at crypto. Python or Sage. Sage is some libraries built on top of Python. And then also just knowing a lot of the university level math, like I think discrete math, maybe they might cover some of this stuff. Or if there's also, if you're looking at graduate, I think undergrad has an intro to crypto, but I know that class teaches more into the theory on crypto. So forensics is you generally have some image or some sort of media, and then you're trying to extract information from it. Let me actually briefly do something. Let me do this. So let's see if I can search. So something that's actually really fascinating, especially if you're just starting off. So this image looks like a tree. You just is like some trees and in the sky. But then if you actually take the bottom least 2 bits, you actually get this image. And it's actually hidden inside this image the entire time. I think if we have more time, if we have time at the end, I can actually maybe do a demo, and maybe it'll be successful. But oops. I think I must have. Let me move that. Okay, let me continue that. So it's kind of some stuff you can look into forensics. It's kind of cool. And then, there's some tools, Wireshark. Sexhelp is one of my favorite tools for doing this kind of stuff for image steganography. Hex editor is very useful to look at the binary data to see how files are kind of store that image data. Binwalk helps you locate files that are actually hidden inside other files. And then strings lets you view a lot of the readable strings really easily. So Pwn is basically you're given an actual binary that is kind of compiled with a language maybe like C or Java. I guess not Java most of the time. It's mostly C or C++. And then you kind of break it. So the idea here is a lot of programs, they have just vulnerabilities at the low level. Some of the tools that I find useful, GDB, Jeff. I use GDB and Jeff together. Some people use Pwn debug. Some people think that is better, but I beg to differ. So for reverse engineering these binaries that are compiled, I would recommend getting some tool like Ghidra or IDA Pro. Ghidra is like free as long as you trust the NSA because they wrote the program itself, but it's open source, so who knows? It's probably doesn't have any things in there, but you can't fully trust the NSA. The IDA Pro is sort of free. They have recently given like a free version with a decompiler in 7.6, but it's very restrictive. If you want to get the full version of IDA Pro, it is hellishly expensive. So we're looking at maybe 3-4K at the minimum. But yeah.
For one decompiler and the base copy by Pro.
Yeah. So IDA Pro can get very expensive very fast. But their argument is it's for the companies. So companies can pay that. But Ghidra is there, it's free. It has a decompiler, so if you need that, you can definitely use that. I've heard that Binary Ninja is also another tool that lots of people like using, but it definitely is cheaper for students. So there's that option. In Python, when you're writing exploits, I recommend using something like Pwn tools. That helps you kind of make your exploits a lot more easier to run. And then there are some websites that kind of you can use to practice it. Pwnable KR is something that I started off with back in the heydays. And Pwnable TW is a little bit more difficult, so I recommend starting from here, from KR. There is a Nightmare series, or that's what they call it. And it basically has a bunch of challenges that are old, and this guy writes a bunch of write-ups about them. So actually, if I click on that, it'll actually have it has some kind of readmes for tutorials. And if you look at the actual the associated GitHub repo, he actually also has a bunch of different challenges, and each of the challenges actually have the original challenge. Like say this one has like the binary itself, and then also an exploit that you can actually run and hopefully it works, and then like a write-up. So this one so you can use this to like kind of learn all the basics of pwning. And then I would also recommend, if you like watching video, don't like reading, Live Overflow did like a very comprehensive binary hacking series. Let's take a. Okay, so. Okay. So yeah, so he's done a lot of videos, and these are all pretty nice to go through. But he generally talks very fast, so you generally want to go and kind of watch this slowly. Maybe you need to watch it multiple times, can't do ×2 speed on this. So some screenshots, that's GDB and Jeff. It looks a lot nicer than if you ran GDB itself. So I would not recommend running GDB without installing some other plugin on top of it. This one is an example script in Pwn Tools. So reverse engineering, it is you're looking at some program. This time, you're not trying to exploit it. You're just trying to see what it does. You're trying to analyze some of its patterns, how it works. Maybe it's encrypting some password or flag that you want to kind of decode. It has a lot of, sometimes you might need to employ dynamic analysis, meaning that you have to run it and then try to trace what it's doing. Because some binaries are very large and very hard to reverse engineer. So again, GDB is useful for debugging. strace is like a very nice tool that you can use to trace system calls that the program will make. System calls are generally any functions that are called into kernel, such as writing or reading from a file, stuff like that. And then you want to have some disassembler, decompiler, Ghidra, IDAPRO, mentioned earlier. So some other reverse engineering resources you can look at. Codebreaker, NSA Codebreakers is happening right now. Flare-on's happening right now. They're both full of reverse engineering stuff. Yeah. And then web, we kind of did a web challenge earlier. The XSS attack that we did earlier, that's kind of what you kind of will see in web. Generally in web, you're looking at sometimes users kind of do not sanitize your input. Sometimes you have stuff that you get, as a user you can give, but then the web application doesn't actually make sure that you can't do any funny business with that. And sometimes with web, you have language features that are just kind of jank, and then some edge cases with that. So tools, Burp Suite, the browser dev tools is useful to look at client-side code. Burp Suite is useful if you want to go man in the middle if you want to see kind of what kind of requests your browser is making. So I got a question asking, will there be access to these slides afterwards? I believe you should be able to have access at this point if you follow this link. If it doesn't work, please let me know. But I believe this should actually work. Keyword is should. But I will confirm that right now, since someone is complaining. Okay, so I am getting, the link should be correct. Let me go and do that as well. Oh. So this should be accessible. I do see some people already on the slide, so you should be able to have access. So Python requests is something if you want to automate requests. And then for kind of practicing, Hack the Box is something that is very often has a lot of web challenges, and also TryHackMe is another useful resource. I know a lot of them, TryHackMe especially, has a lot of tutorials that you can actually work with. And if you want help with web, you can also ask our in-house web god, Kai, or you can ask him for web challenge questions. Supposedly you could have asked this guy who is Paradox on the Discord, but he has been MIA for a long time.
Yeah.
So I have no idea if he is actually going to be able to help, but he's also pretty decent at web and pen testing. Last words, I think competing well in CTFs take a long time, and we will be going through like a workshop series that you can do to like learn different categories, but a lot of work has to be done outside as well, kind of practicing different challenges that you're interested in. So definitely do, if you want to do well in this, you want to spend some time. And also, like, learning CTFs is not a straight path. There's a lot of kind of things that you could look at and explore, and there's no really one great right path that that you can follow. So another quick video by Live Overflow.
Maybe you think there is some kind of shortcut, or at least a very efficient path. You hope a professional or experienced person can easily tell you about a clear path to success. I certainly had exactly those thoughts several years ago. I got frustrated why nobody would write down a clear guide. I felt somewhat entitled that I have a good experience already, I just need some guidance or mentoring. But the truth is, there is no efficient path. Truth is, it just takes years of experience. So if you think that somehow it would be easier with a study plan, it's not, so forget it. I'm sure you know this interview question. What advice would you give your younger self? And for me, I don't know. While certainly thinking differently at the time, in retrospect, I don't think there was anything bad or inefficient about the path I took. Of course, I could help my younger self understand certain concepts better and faster, and that's what I try to do with the videos. The videos cover exactly what I would tell my past self, but I couldn't lay out a path of do X, Y, and then Z. There is no secret step-by-step guide. It's not a straight path, but a web of interconnected topics, layers, and dependencies, and you're free to walk and jump between stuff however you want. Truth is, anything you do, any tutorial you follow, any project you start and never finish, any dead end you head down, it's not wasted. It's all experience that is accumulating over time. If I learn anything about hacking, what it means, what it is, then, at least to me, it's not really something I can get a hold on. It's an abstract, artistic, and broad term for many different things. Truth is, hacking is just learning IT stuff, but kind.
Oh yeah, so I stopped it there because he goes on very long ranting about what it means. So I definitely encourage you to watch the entire video, but I don't know if we actually have time. Actually, we might actually have a little more time, so I can actually play the rest if you all want. But I will actually do this first. So I will pull this up. So this is what you would call the StegSolve. So I actually downloaded the challenge. Let's see if I have it. So this one. So this, sorry, I can't really zoom in, but this image is basically the image that we saw earlier that I downloaded from Wikipedia actually. So you can see this is like a nice image of the trees, but if I go and just scroll into different views, you can see some of them are going to be a little bit funky. And then if I go there, oh, suddenly you see a cat. And if you look at the low planes, you can see that image of a cat is at the bottom. So yeah, so that is basically, so the reason why you don't see the cat, if we're looking at this original image, is because the cat is actually in the pixels of the low bits, which if you're looking at it on a naked eye, you can't really distinguish the image because it's kind of noisy image. But if we start looking at the kind of the low bits of this image, you begin to see like these hidden stuff in here. And this is just one example of what steganography could be. And actually, I might go and
hacking is just luck. Maybe now you say, well, tell us about your path then. Clearly it got me somewhere, right? Maybe that's the ultimate guide. Well, there are a few things I can mention. My path is also full of just luck. Opportunities I have never planned for, so it's also somewhat not applicable to anybody else. Nevertheless, here are a few checkpoints that maybe give you some idea. As a kid, I started with some HTML. Then I got a book about Visual Basic Script and I wanted to write an operating system in it. If you have ever written Visual Basic Script, it's a bit like JavaScript, you know how ridiculous that idea was. But that didn't hold me back. I asked this question in a forum and was called a dumb troll. I was really sad that day, because I was just a kid trying to learn something and I had no idea what it means to have an OS. Anyway, at some point I got into web programming with PHP, so I had to learn actual HTML, CSS, JavaScript, PHP and MySQL. I started and abandoned several browser game projects. Then I heard about SQL injections and I did a school project on it. Here I wrote a test application and explained how injections work. I started to learn Java and got into Android app programming. Did some C++ and a bit of game programming. Made a shitty Monopoly clone. Then I did some Google Wave gadgets. Does anybody remember that? I was just a dumb kid and my code was ugly, but my poll gadget got some attention from professional. That was cool. I learned more about computer science fundamentals in university, data structures and algorithms. Learned about Linux because I started to use it at work. Joined the hackerspace and learned about Arduinos and soldering. And then I guess the major turning point, I discovered my first CTF, the Stripe CTF, and got hooked on war games and other challenge sites. And essentially here I am now. And now I'm a freelancer doing security, code audits, pen testing, application security and that kind of stuff. And please don't ask me how to get into freelancing. I have no clue how to do it. I met a guy who knew a guy who recommended me and here I am. So that was not planned at all. And looking at my history, imagine that these are just large checkpoints. It's not a straight path, it's traversing through a jungle of different topics. It's kind of like a fractal or the coastline paradox. If you zoom in, you uncover even more complex lines. There's a lot of stuff I did not mention in this high-level view, like making RPG Maker games where I was first exposed to if-else logic blocks, or modding my calculator with a window and LEDs, one of my first exposures to electronics. And if you ask me where to start, where should I point you to? Is the start the first HTML line wrote as a young kid, or is the start when I had already years of programming experience and discovered CTFs? I have no answer for you, you have to figure that out yourself. But one truth is, I didn't discover any secrets. There is no anonymous secret hacker organization with forbidden knowledge. I simply apply the knowledge that I gained about computers over the years. You know, programmers use the same knowledge, but just think differently. They think, how can I make it work? And a hacker thinks, how should you implement it so that it's secure? And what could a lazy programmer do wrong? Truth is, the more you understand how something is built, you can also think about how it could break. So I'd say 95% of what I'm doing is just learning about how computers work. And by that I mean learning a ton of different programming languages, frameworks, concepts, and so forth. Over the years, I gained a very good broad basic understanding from low-level logic gates over simple circuits to PCBs and chips, microcontrollers, low-level programming, assembler, C, firmware, operating systems, higher-level languages, language and programming concepts, data structures, file structures, 3D programming, networking, cryptography, servers, server administration, websites, frameworks, databases, web apps, mobile apps, math, machine learning. The list is endless. And you see, nothing on this list screams hacking or security because this knowledge is just the base requirement, the tool that I use to do my job as a professional hacker. Like I said, it's not secret knowledge. It's everything a programmer, sysadmin, or whoever would learn, just applied a bit differently. So I'm thinking, what could go wrong? How can files be exposed? How could I gain access without a password? How could I modify something that shouldn't be modifiable? How can I manipulate the output, and so forth? And maybe it's surprising to you, but that's not different from what a programmer or IT architect would do. They use the exact same technology, just have different thinking patterns, different problems they try to solve. So they think, how could I use these things to build a social network? How could I build a time-lapse camera? How could I make a fun game? Different problems, different goals, but based on the same knowledge. And the security-focused stuff like conference talks, CTF write-ups, trainings, academic papers, blog posts are essentially just sharing cool ideas how to apply this knowledge in a security-focused way. And that is not different to a programmer sharing techniques on how to handle huge data sets efficiently or how to implement a game AI. Don't think of hacking as anything crazy or special. It is based on exactly the same thing, just with a different angle. Breaking, not building. So to summarize, hacking requires a lot of knowledge about computers. And I say generic computers because it could literally mean anything IT related. And learning a wide variety of technologies and gaining experience and knowledge to draw from just takes time. It takes years. So any game you develop, any Minecraft redstone circuits you build, any boring sorting algorithm, any math class, any mobile app you start and abandon, anything you do is knowledge you accumulate and eventually can use. So one general advice I give is, it takes a lot of time, so make sure you have fun. Enjoy learning about computers, enjoy programming, enjoy following tutorials, enjoy learning a new language. Whatever it is that you have fun with, it will keep you motivated over the years. Don't get me wrong, you don't have to first program for years and then get into security. You can do it in parallel. When you write an Android app, look into the official Android security tips. Think about what could go wrong, what happens if you don't follow it. Play around with it. And maybe at some point you want to build a web API to be used by the app, and suddenly you learn web development and server administration. Then you have to debug your connection and how that can be used to analyze and test stuff. This is essentially the process you will be doing for the next few years, and that's what I do all the time. You know, the thought of being able to hack an iPhone or gaming console or banking terminal is motivating, but good chance is that you are just very, very far away from that. I'm at least not there yet. I failed my Nintendo Switch hack attempt. I barely understood the surface. But that's fine. I keep learning, and I have a ton of fun with learning basics and learning a new programming language and learning new technologies. And in a few years, in 2 more console generations, maybe I know enough to join one of those teams. I know you might still feel frustrated where to start. But if you feel frustrated, then that's probably because you picked a target way too large for you. If you don't know
Okay, sorry. Let's see. I have one more slide, and then I think we are done for today. So let's go and close that. So what can you do to get started? So first of all, I encourage you to actually go and actually do some CTF. I know the most recent one, I think it's Sunshine CTF, and I believe some guys were going to set up a team.
Is it this weekend?
I believe it's this weekend. Let me double check that. Let's see.
Are we creating a Discord channel for it?
Yeah, we will be creating a channel and do all that jazz. So yeah, it is this weekend. So that will be something that we'll be doing. So there are some of the easier CTFs are like high school CTFs, high school level CTFs. So Pico is a high school HS CTF, which is high school CTF. And then I would also, if you want to look at more CTFs, you want to look at this CTF time. And this will kind of usually tell you like some of the CTFs that will be coming up. So generally, if we're looking at CTFs that are nice, you want to look at CTFs that have low weight. So maybe like these kind of stuff. Around 25 to 35, that's about the easier ones. Except for a couple of them, they are just newer ones. But if we're looking at consistently 25-ish, those are generally more easier ones. And they're also relatively decent. Let's see. And we will also, CSG will also like participate in some CTFs throughout this semester, so that you know that those will be probably easier. So we'll be doing Sunshine, which is happening in one day, I think. It'll be tomorrow at 14 UTC, which is around 11-ish, I think, 11 a.m. And also, we have a CTF team. If you want to create an account and join our team, feel free to do that. You can just request, I believe you can just request entering here, and then it should we should be able to allow you from there. So when there are no CTFs, I recommend you to play war games. So these are kind of like CTFs. They have the kind of similar challenges, but then they are kind of you're able to play them on your own time. So for general CTFs, CTF Learn is something I like that has a lot of the easier challenges. Over the Wire is also a beginner-friendly one. Crypto Hack, Crypto Pals, Model KR, those are more specific. So groups, we have the CSG Discord. If you're not in that already, we have weekly workshops, and you're in one right now. There's the Cybersecurity Club. That's also another. So I think they say they're doing a networking event from Palo Alto. And then I believe this is the Cyber CSC Discord link, I think. Can someone? Okay, yeah. Cool. So that is that. Can we do it even though we have no prior experience? Obviously, you can't do it. You can. A lot of these challenges, you're meant to kind of do them and try to learn on the spot. And that's kind of how, for example, I got started with CTFs. Was like, I had no idea how to do any of this stuff. I just Googled everything, and then slowly learned kind of how to do these challenges. There's a lot of resources, which is kind of allows you to figure out how to maybe start learning it. But yeah, definitely encourage you to do it even if you have no experience. I believe that is, oh yeah, the last slide is, if you have any questions that you want to DM a specific person, just ping someone from the CTF committee. Or this, I believe the CSC meeting tag as well. I believe we are at some point going to merge those. But yeah, we can feel free to ask anyone with the orange tag. So how do we join the team for the CTF this weekend? I believe when we create the account, we should post the password, username and password for anyone to log into, and you should just be able to use that to log in. Depending on if anyone actually wants to show up, we may or may not have people show up in the CSG lab, which is 4.619, which ECSS 4.61944. It is like one of the hallways. You'll see like the green CSG logo somewhere if you keep searching. Is that, huh? It's 4.619. Let me, are there any other questions? Yeah.
That was the meeting tomorrow, right?
Huh?
That was the meeting, like what, for that room, is that tomorrow or some other day?
That is for tomorrow. If anyone wants, I don't know if there are any. I will see if there are any. To see that there will be some officers that will show up. But yeah, that's for tomorrow, for the CTF. If y'all want to like meet in person and do like challenges together.
What's the skill level for that?
Huh?
What's the skill level for that?
Generally, you have some beginner level challenges. I mean, if you need help on a challenge, you can ask us in person. And generally, the lower point challenges will will be easier because, well, depending on whether if the CTF is dynamic weight or static weight. But generally, I would say eventually we'll figure out which ones will be easier to do. And I would recommend doing those. Let's see. Did Paradox get arrested? I have no idea. He never.
I know where you're.
Oh, you know where he is.
Yeah. Nothing. Can't say.
Ooh, is this
Nothing suspect.
Oh, okay, I see. Okay, yeah, I believe that is the last slide. Appreciate everyone for coming. Next week we will be doing web. And then we'll have Kai be doing that right